Welcome to your last video of the week. We're going to start a new chapter and a very brief chapter at that, in chapter 12 on sequences and a little bit on series. The reason why we're going to spend just a little bit of time on it is because for those that are 11th graders in here, I want to make sure that you see and understand some of the sequences for the MCA test that's going to happen in a couple of weeks. So it's going to be actually a pretty quick one, but we'll go ahead and wrap up anything we need to wrap up next week when I return. For right now, we're going to do 12.1, and it's going to all be about sequences. First things first, you got to understand what a sequence is. A sequence, this is very wordy. I do want you to write it down, but it is very wordy in terms of what the actual definition is, and I do want you to write this down. A sequence is a function, okay, a function whose domain, the input, remember domain is input, is a set of consecutive integers starting at n equals 1, okay, so it's going to be a domain of a bunch of integers starting at 1, 2, 3, 4, 5, 6, 7, etc. And then the values in the range, the output, are called the terms of the sequence. So again, as you write this down, think you're going to be inputting into this function 1, 2, 3, 4, 5, 6, 7, 8, etc. And then you're going to get out, based on what that function is, you're going to get out a bunch of numbers, which we call the range, and we're going to call those outputs or that range the terms of the sequence. Okay, now the only other thing I may say later on is that they may start at 0 and go 0, 1, 2, 3, 4, 5. But for right now, let's go ahead and assume that we're going to start with n equals 1. So in other words, and again, if I'm going too fast, feel free to pause this at any point, especially if I'm going too fast through an example. More simply, a sequence is a pattern of numbers described with an equation. So, I mean, one of the easiest things you can think about is 2, 4, 6, 8, 10, 12, 14. Okay, that is a sequence. Okay, the sequence really is take the previous number and add 2. Or you could also say take 2 and multiply it by whatever number you're at. So 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, etc. Where 1, 2, 3, 4, and 5 are my inputs, and then the 2, 4, 6, 8, 10 are my outputs. Okay, let me actually write that down, and I think that's a great example. So again, if I think about 2, 4, 6, 8, 10, 12 being my sequence or being my pattern of numbers, okay, this is really 2 times 1, this is really 2 times 2, this is really 2 times 3, this is 2 times 4, etc. Okay, so you can see there, really my equation is 2 times whatever my input is. My input is 1, 2, 3, and 4. And when I go ahead and chuck it into the equation of 2 times whatever that number is, I get out 2, 4, 6, 8, 10. So 1, 2, 3, 4 are my domain, and 2, 4, 6, 8, 10, etc. are my range, or what we're going to call, these are what we call our terms of the sequence. Okay, sorry for the color, it may not show up very well on this one. Okay, so in general, you have a sub 1, and that's how I'm going to refer to it, a sub 1, a sub 2, a sub 3, a sub 4, dot, 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 all the way up to a sub n, where n is either the one at the very end or the infinite number at the very end of the sequence. Some of the sequences go on forever, some of them go ahead and stop. Okay, now understand, we've talked about it before, when it's a sub number like 1, 2, 3, 4 in this picture, okay, those do not have any mathematical relevance. Okay, they're just labeling a term. A sub 1 is the first term, a sub 2 is the second term, a sub 3 is the third term, a sub 4 is the fourth term. Okay, now you're going to plug 1 in, plug 2 in, plug 3 in, 4, and plug 4 in. It just signifies that in this picture, the 1, 2, 3, and 4 just signify this is the first term, the second term, the third term, the fourth term, whatever it might be. So a sub 1, a sub 2, a sub 3, a sub 4, all the way up to a sub n, okay, is where 1, 2, 3, 4, all the way up to n are the input or the domain. We talked about this already, where 1, 2, 3, 4, 5, etc. are the domain or the input. And the set a1, a sub 2, a sub 3, a sub 4 are the output or the range of the sequence. So you're always going to plug in 1, 2, 3, 4, 5, 6, 7. You're always going to plug in integers starting at 1, at least for now. And you're going to get out some number, and that number that we're going to get out, which we call the range or a term, we're going to signify as a sub 1, a sub 2. So what do you get when you plug in 1? Well, you get a sub 1. When you plug in 2, what do you get? You get a sub 2. Okay, and so we're going to go ahead and label them that way to make our life a little bit easier when these things get a little bit more difficult. One last thing I want you to understand is the idea of a finite sequence versus an infinite sequence. Okay, we know what infinite means. Infinite means it goes on forever. That means finite means something that actually stops. So you can see here on this screen, if we have a finite sequence, okay, it's a limited number of terms. In other words, it stops. It doesn't go on forever. So my very simple example is 1, 3, 5, 7. That's it. Okay, that is my entire sequence. It's 4 numbers. It's 4 terms. That's all it is. Okay, and so if I have this, all I have is really 1, 3, 5, 7. That's a finite sequence. Unlike if I have an infinite sequence, it continues without stopping. So you can still see there, I still have 1, 3, 5, 7. But you can see I have a dot, dot, dot there. Means, hey, I have an infinite amount of numbers that actually goes and beyond number 7. Okay, and so I want to keep on going, but I can't go ahead and possibly list all them all because it's infinite. There's an infinite amount of terms that follow the same sequence or follow the same pattern. I'm just going to write the first 4. So we're going to talk about finite sequences versus infinite sequences. One that stops versus one that does not stop. So take a look at this. Let's deal with some actual formulas. Okay, I want you to write the first 6 terms of the sequence. I want you to write the first 6 terms of the sequence. Here's my equation. Here's my equation that describes the sequence. Okay, let's go ahead and write down number 1. It says a sub n is equal to 2n plus 5. Now remember, n is the input. N is what you're actually plugging in. So if I want to write the first 6 terms, I've already told you that the inputs should start with 1, 2, 3, 4, 5, etc. all the way up until whenever we stop. In this case, we're going to stop at 6 because we want the first 6 terms. Okay, and I'm going to see if I can find something that works. I think the red looks pretty good. So if I want this, I want the first term. The first term I'm going to signify as a sub 1. Okay, a sub 1. When I plug in 1, what term do I get out? Well, if that's the case, I'm going to say, well, n is equal. Well, I'll do this. I'll say in this case right here, I'll say, okay, what if n is equal to 1? Well, if n is equal to 1, I know I'm going to take that formula. It's really going to be a sub 1 equals 2 times 1 plus 5. In other words, I'm taking wherever I see an n, I'm plugging in 1 for that formula. So if that's the case, I get a sub 1 is equal to 2 plus 5, and I get a sub 1 is equal to 7. If I do n equals 2, my next step in my next term, I'm going to get a sub 2 is equal to 2 times 2 plus 5. So that means a sub 2 is equal to 4 plus 5. That means a sub 2 is equal to 9. Okay, so just for me to create some space here, I'm going to go ahead and do the next one. I'm going to do when n is equal to 3. I get a sub 3 is equal to 2 times 3 plus 5. Again, all I'm doing is using that equation, okay, to go ahead and plug in the input that I want, in this case 3, and to generate the output. So a sub 3 is equal to 6 plus 5, so therefore a sub 3 is equal to 11. Hopefully at this point you're starting to see a pattern. We had 7, we had 9, we have 11. My guess would be we're going to have 13, and then we're also going to have 15. That's the first 5. One more, 17. Okay, I'm okay with that as soon as you start seeing a pattern, as long as you are correct and you're valid. Okay, you can just go ahead and show me the work on the first few, and then generate the rest if you need to versus wasting time. Okay, what about number 2? What if you have this one? Well, if you have f of n is equal to negative 3 to the n minus 1. Again, I want to use my starting point. My starting point for my inputs are when n equals 1. Okay, so I'm going to go ahead and say, okay, when n is equal to 1, I think I get, I'm going to try and use red again. Okay, f of 1 is equal to negative 3 to the 1 minus 1. That means f of 1 is equal to negative 3 to the 0, and we know everything to the 0 power is 1. So when I do f of 1, I get out 1. What if I do when n equals 2? If I do when n equals 2, I get f of 2 is equal to negative 3 to the 2 minus 1. That means I have f of 2 is equal to negative 3 to the 1 power. That means f of 2 is equal to negative 3. Again, if I do when n equals 3, keep working my way up the chain. I get f of 3 is equal to negative 3 to 3 minus 1. That means f of 3 is equal to negative 3 squared. That means I have f of 3 is equal to 9. Hopefully you're seeing right now that the results are powers of 3. 1 is 3 to the 0, 3 is 3 to the first, 9 is 3 squared, etc. The only thing that's alternating is the negatives. Okay, so when I obviously have, in this case, it ends up to be an odd power, I get a negative. When it's an even power, I get a positive. Okay, so when you look at this, I think in general, instead of me having to go through this whole thing, I know my first three terms are 1, -3, and 9. But then if I keep working up the chain, okay, I should be able to say, well, the next power is going to be 27, but it's going to alternate to negative positive, so it's -27. Then really 3 to the 4 is going to be 81. And then we have -243. Okay, I think that is my sequence that I have for the first 6 terms of the sequence. Now, what if I give you the terms? So in other words, last time I gave you the rule, I gave you the equation, I gave you how to actually generate the terms. What if I flip it on you? Okay, what if I give you the terms and I want you to go ahead and make an equation? Okay, so in other words, can you go ahead and describe some sort of pattern, okay, that's happening with these terms and be able to make and predict what's going to happen going forward? Okay, so like in this one, for example. Okay, if I look at this, I immediately know, and just so we're on the same page, okay, if I have this, I know that this one right here, and again, I'm sorry, I should have not used this color. Okay, if I use this 2, I know this is a sub 1. I know this one right here is a sub 2. I know this right here is a sub 3. And I know this right here is a sub 4. It's the first term, the second term, the third term, the fourth term. Well, if you look at that, you might ask yourself, okay, well, how does the 1, 2, 3, 4, my inputs relate to 2, 5, 10, 17? How does 1 relate to 2? How does 2 relate to 5? How does 3 relate to 10? How does 4 relate to 17? Okay, and guys, right away, to be honest with you, it's not the easiest thing in the world to go ahead and describe and come up with a blue. You got to think a little bit. You got to be a little creative in terms of how you come up with these numbers. Okay, I see that 2, 5, 10, and 17 are all one number more than the 1, 2, 3, 4 squared. So for example, 1 squared is 1, and if you add 1, you get 2. 2 squared is 4, when you add 1, you get 5. When I see 3, 3 squared is 9, plus 1, you get 10. And if I get 4, 4 squared is 16, plus 1 is 17. So I think in general, I can say this, well, a sub n, whatever my nth value is, what is my 10th term, my 100th term, my 243rd term, I know in general, I'm going to take that n value, 1 squared, 2 squared, 3 squared, 4 squared, I'm going to take it, I'm going to square it, so I did 1 squared and I got 1, but then I had to add 1 to it. Okay, so I think in general, I think that's going to describe my pattern. If I plug in, if I wanted to, for example, if I wanted to know a sub 4, we already know that a sub 4 should give me 17, but if I do that, it's really 4 squared plus 1, which hopefully is 17, which is exactly what we generate right here. So that rule right here tells me how to describe the pattern in general for whatever term I want, not just the four terms that's listed. But now the problem asks me to write out the 15th term. Well, that means if I have a sub 15, should be 15 squared plus 1. And we should know that 15 squared is 225, so 225 plus 1. So a sub 15 should give me 226. Okay. Go ahead and try and do this one. I'll give you a few seconds. Try and do number 2. Again, I'll try and help you a little bit. This right here is a sub 1. This right here is a sub 2. This right here is a sub 3. This right here is a sub 4. So now ask yourself, how does the 1, 2, 3, 4, the inputs of my function, relate to -4, -8, -12, -16? I think I see this. I think I can see multiples or multiples of 4, 4, 8, 12, 16. I can see they're all staying negative, so I don't need to go ahead and worry about alternating negatives or positives. Okay, so I see that I think my rule is going to be this. A sub n for the nth term, whatever it is, 10th term, the 20th term, the 200th term. Okay, a sub n is going to be -4 times n. When I do negative 4 times n, okay, for example, we can check it to make sure it works. What if I want to do a sub 3? Well, I know that a sub 3 right now should be this one right here. It should generate negative 12. When I plug in 3, I better get out 12. So I do negative 4 times 3, because 3 was my n. I get a sub 3 is equal to negative 12. Sure enough, it works. Okay, and so now it again asks me, what about the 15th term? Well, if I do the 15th term, it's a sub 15 is equal to negative 4 times 15. And I know that when I do negative 4 times 15, I should get negative 60. So I know I can predict that if this pattern continues, I know I'm going to get negative 60 when I get way out to the 15th term in the sequence. Now, I'm just going to show you this one, number 3. Go ahead and write this down. Number 3 is 3, 8, 15, and 24. The first thing I'm going to ask you on Monday is, what is the equation, or what is the rule for this sequence? This one's a little bit harder. 3, 8, 15, 24. Give me something like a sub n is equal to whatever that is. Okay, what is the rule that describes this pattern? 3, 8, 15, 24. Now, there are two kinds of sequences. There's arithmetic. Okay, it kind of looks like arithmetic. We call it arithmetic when we talk about sequences. Arithmetic sequences, okay, which arithmetic is usually kind of the basic functions, okay, of adding and subtracting. Okay, but then we also have geometric sequences, which we'll talk about on Monday. Arithmetic sequences, by definition, is this. An arithmetic sequence are a specific case of sequences where the difference in consecutive terms is constant. It's like the last one that we did in number 2. Okay, there's a constant difference of negative, well, I shouldn't say that. Number 2 we had a different multiple, so I shouldn't say that. But for example, one that we did at the very begin, it should say 2, 4, 6, 8, 10. Okay, the common difference between those are 2. And so that would be considered an arithmetic sequence. When the difference between consecutive integers is the same number, we're going to call that an arithmetic sequence. That difference that we're going to call it, that common difference or that constant difference, is what we call a common difference, and we're going to call it D. Okay, and so we might want to make that note. If we, for example, if it's 3, 6, 9, 12, 15, 18, 21, etc., obviously that sequence has a common difference of 3 between every one of the integers. We'll call D 3 because we have that common difference between each term in our sequence to be 3. That would be an arithmetic sequence with a D value of 3. In general, okay, if I actually want to go ahead and come up with an equation that describes all arithmetic sequences, because they all act the same, whether it's 2, 4, 6, 8, 10, or 3, 6, 9, 12, 15, or 4, 8, 12, 16, 20, okay, all arithmetic sequences act the same. They all have a common difference, and they all act in the same behavior. So in general, the nth term, remember we talked about the nth term. The nth term is whatever term I want out there in the future, whether it's the 10th term, the 20th term, the 25th term, the 100th term. Okay, the nth term of an arithmetic sequence, with the first term being denoted as a sub 1, so notice that I'm starting with n equals 1. I'm starting with the first term to being 1. And the common difference D is this. A sub n is equal to a sub 1 plus the quantity n minus 1 times D. Again, a sub n equals a sub 1 plus the quantity n minus 1 times D. In general, guys, this is the term, or this is the rule for this type of sequence, when there's a common difference, and we call this an arithmetic sequence. So let's try one. Let's just try one of these. Okay, it says determine if the sequence is arithmetic. If so, write a rule for the nth term. Okay, then find a sub 20. Okay, so in general, first thing you're going to be asked to do is this arithmetic? And the easiest way to go ahead and do this, guys, is to see, is there a common difference between it? Okay, so if you look at number 1, go ahead and write down number 1, negative 7, negative 10, negative 13, negative 16. Okay, I can see from here to here, I'm losing 3. From here to here, I'm losing 3. From here to here, I'm losing 3. Okay, because I gave that all to me, I have to assume that that stays the same the entire time. And so if that's the case, I can see that my common difference is -3. Therefore, that definitely is arithmetic. Well, if that's the case, if I go back to this, if I go back a screen and look at my general sequence or my general formula for an arithmetic sequence, I really think I need to know two things. I need to know a sub 1. I need to know my starting factor because I need to know where to start my sequence. And I also need to know by how much am I increasing or decreasing every term. Okay, the n's can stay the same because the n is kind of the variable, the input. Remember, n is my input, 1, 2, 3, 4, 5. So the n's can stay. So the really only thing I need is a sub 1 and d. So if I look at this, well, I know that -7, okay, I think this is a sub 1. That's my starting point. And I think you just found from down below, okay, this right here, this is my d. My d is my -3, is my common difference. And so, if I come over to the side and I try and go ahead and write this out, I know that's a sub n equals a sub 1 plus the quantity n minus 1 times d. Plug in what you know. You have a sub n equals, a sub 1 is -7 plus n minus 1 times d, which is -3. Okay, now you can go ahead. You could leave it like this, but we all know it's something that we can simplify pretty easily. So let's go ahead and do that. I'm going to distribute everything on the inside. So now I have a sub n is equal to -7, and that's not a plus. -7 minus 3n plus 3. And if I take a look at this, -7 plus 3 is -4. So I have a sub n equals -4 minus 3n. Okay, right there, guys, that's going to describe my pattern. Now, you can go ahead and check if you want. You want to check in a sub 1, you want to throw in a sub 4 or whatever it is. I guarantee you're going to generate the first 4 numbers of the sequence. The only other thing they ask is, I want to find a sub 20 then. Well, a sub 20, based on my rule, better be -4 minus 3 times 20. And therefore, I have a sub 20 equals -4 minus 3 times 20, I think gives me -64. Okay, the nice thing is this. I mean, the reason that we do this is for this reason. Do you really want to take the sequence and write out the first 64 terms, or excuse me, the first 20 terms, or the first 100 terms, whatever you're trying to find? No, I want to come up with a pattern. I want to come up with a rule so I can quickly go ahead and jump right to it. Okay, so in this case, I don't want to write out the first 20 terms to get the -64. Instead, I want to say, look at the first 4 terms, create a rule, and once I have a rule, I can plug in whatever term I want. What about this one? What about number 2? I have -8, -4, 0, 6, and 12. I think I see there, at least initially, I think I see I have an increase of 4. I have an increase of 4. I'm on a good track here, but then all of a sudden I have an increase of 6 and an increase of 6. That tells me right away, while this may very well be some sort of sequence, okay, and we might be able to describe this later on, it's definitely not an arithmetic sequence. The terms in between the difference between every single one of the terms better be exactly the same. If it's not, okay, we have an issue. So this is not arithmetic. It might be a different kind of sequence that we could describe later on, okay, but it's definitely not arithmetic. It's not true. This is not going to work for what we're trying to accomplish. Okay, now the last couple things I want to do are a little bit more difficult. Okay, go ahead and write this down. So I give you a couple different things. I give you the common difference, so you know it's arithmetic. And I give you the 27th term. A sub 27 means when I plug in 27, I get out 263. In whatever formula or rule that I'm going to generate, when I plug in 27, I better get out 263. Okay, and so when you look at this, I got to write a rule for the nth term. Okay, so I'm going to go ahead and plug in at least a little bit of what I know. I'm going to start with the general sequence of an arithmetic sequence. I know it's a sub n equals a sub 1 times n minus 1 times d. That's a general term. We should all know this. Okay, that's the one we just wrote down a couple slides ago. Okay, now, I know the 27th term. So in this case, n is 27. So for the time being, I'm going to say, okay, I know for sure at least when I plug in 27 for n, I get out 263. Okay, so first thing I'm going to do is this. I'm going to say, okay, 8 sub 27 equals. I don't know, I definitely don't know what a sub 1 is. I don't know what my starting point is, so it's got to stay the same. I don't know what it is yet. Okay, plus, I have 27 minus 1. Again, my n is 27, and I do know my d. My d was 11. Okay, but now if you look at what I just created, I actually know what a sub 27 is. From the problem, I know a sub 27, this box right here, is 263. So let's plug it in. I know that this generates 263 is equal to a sub 1 plus, really, 27 minus 1 times 11. Okay, well if I do 26 times 11 on my calculator, hopefully you're doing the same thing, I get 286. So I get 263 equals a sub 1 plus 286. I think most of us would probably subtract 286 from both sides. That goes away, so 263 minus 286 should give me negative 23 for a sub 1. That tells me my starting point for this sequence starts at negative 23. That's good, because now if we go back to our previous problems, I think I told you in this very starting sequence here that you needed to know a sub 1 and you needed to know d. Okay, well we know d was 11, and we just found a sub 1. So if that's the case, I think I can go back to my problem here. I have d is 11, and I have a sub 1. So if I want to write the term, a sub n equals, I'll write the general term again, a sub 1 plus n minus 1 times d. Well now, it's a sub n equals, I know my a is negative 23, so negative 23 plus n minus 1 times 11. Now, if you take a look at this, I think I can simplify this. I'm going to distribute the 11 of both things on the inside. And if that's the case, I get a sub n equals negative 23 plus 11n minus 11. So then if I get a sub n equals negative 23 minus 11 more, should give me what? Negative 34 plus 11n. I think right there, guys, is my general sequence for this situation. Now, we can check it. Plug in 27 if you don't feel comfortable. If I plug in 27, and I'll do it right below my answer, a sub 27 equals negative 34 plus 11 times 27. When I do that, negative 34 plus 11 times 27, I think I get 263. Well, if you look in your problem, when I got a sub 27, should you have gotten 263? Should these match a sub 27? Should that match 263? Absolutely. That's exactly what we did. So we got the right answer. My general sequence, or my general rule for the nth term is negative 34 plus 11n. Last, what if I give you this one? Go ahead and write this one down as well. Now, we know that if we want to write a rule for the nth term, if I want to write an equation that describes this pattern, I know I need a sub 1, I need my starting point, and I need to know by how much it's increasing or decreasing by. I need to know my common difference if this is an arithmetic sequence. Okay, and so I think I'm going to end up having to go ahead and create some sort of system of equations. Let's check it out. Okay, for example, if I looked at when I plug in 10, I know the general rule. I'm going to write up on top. My general rule for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Again, that's my general sequence. Okay, well, if that's the case, I can now go ahead and plug in 10. If I plug in 10, I can say, okay, it's a sub 10 equals a sub 1, I don't know, so I'm going to leave it, a sub 1 plus n minus 1, so in this case 10 minus 1 times d, and again I don't know that as well. So in this case I really end up having two variables, okay, which should trigger some memory in terms of two variables, two equations, probably going to develop some sort of system. Okay, so I have a sub 10 equals a sub 1 plus really 9d. Can't go much further than that, although what can I swap out here? Do I actually know what a sub 10 is? I think I know a sub 10. If I swap it out, I think from the problem, I know that a sub 10 generates 148. That way I only have two variables left. Okay, here's one of my equations. Okay, well what about the other one? I also know that a sub 44 gives me 556. So I plug in 44, a sub 44 equals a sub 1 plus 44 minus 1d. Again, I'm just plugging in 44 wherever I see an n in my equation. I know a sub 44 generates 556 is equal to a sub 1 plus 43d. There's my other equation. Now it's completely up to you. I have two equations with two variables. That's a system. Okay, we should be pretty darn good at this. I'm going to choose to go ahead and solve the first one. Okay, if I solve the first one, I think I'm going to solve it for a sub 1. So if I do that, I believe I get a sub 1 equals 148 minus 9d. And how am I doing that? All I'm doing is subtracting 9d from both sides to get a sub 1 by itself. And when I do that, I get a sub 1 equals 148 minus 9d. Now, we should know how to do here. I'm going to take a sub 1. I'm going to plug in wherever I see an a sub 1, the second one. This is algebra 1 all over again. Okay, so I'm going to try and create a little bit more space here. So that means I have 556 equals, I'm using that second formula. A sub 1 used to be just plain old a sub 1. Now it is 148 minus 9d plus 43d, still from the original equation. So that means I have 556 equals, well, when I go ahead and combine the d's, I have negative 90 and 43d. I think I get 34d. So I get 148 plus 34d minus 148 from both sides. When I do that, that goes away. So now I get 408 equals 34d. Divide by 34 on both sides. I think I get a common difference of 12. Okay, and when I do that, that's going to be good because now if I can take 12 is equal to d, can I not just plug it into this equation here and generate a sub 1? So in other words, a sub 1 is equal to 148. I'm using the equation in the middle of the screen right now, 148 minus 9 times 12. And when I do that, I believe I get, I'm going to check it on my calculator too, but I believe I get 40. If I take out my calculator, please do the same thing and check my work. 148 minus 9 times 12, I think I do get 40. Now all of a sudden, guys, I've generated two things that I have, or I needed to go ahead and make my equation. I have the common difference d, and I also have a sub 1. So my final equation, okay, I'm just going to go ahead and erase some of this to create a little bit more room. I know my general equation starts with a sub n equals a sub 1 plus n minus 1 times d. So if I plug in what I know, I have a sub n equals, I know that my a sub 1 is 40 plus n minus 1 times my common difference, which I found to be 12. Go ahead and distribute to both sides. So a sub n equals 40 plus 12n minus 12. Combine like terms, I get a sub n equals 28 plus 12n. Again, you can always check your work. That's a nice thing about these problems. Always check your work. If you don't think you're right, plug in 10. And when you plug in 10 according to my problem, I better get 148 out. It works. If I plug in 44 for a sub 44, my problem, I better get out 556. It works. Here is my final answer. Tonight you're going to be working on arithmetic sequences. I'll see you guys on Monday. Looking forward to seeing you guys. Here's your homework. Have a great weekend. I will see you on Monday.